We are continuing with linear regression. So we need to look at scatterplots. Yesterday we were given linear tables and lines on a graph and asked to write the equation of the line. So today we have a scatterplot. So the lines are not the points are not in a perfect line, but we need to find the line of best fit. That is your trend line. So we look back at the vocab. Trend line, a line on a graph showing the general direction that a group of points seem to follow. So we need to create a line here. Let's see, what does it say? Draw a line of best fit. So create a line that goes through here. So let's look, and we need one with arrows. So I'm just going to kind of make one and kind of thicken it up a little bit. I like different colors. A bright pink would be fun. And then arrows. You don't have to make yours exactly like mine, but let's look and see how this line should look. I'm going to zoom in a little bit more. Issues. Oh. I hate how that thing pops up. It keeps on popping up, and I can't move it. There we go. Okay. So whenever you do a line of best fit, you want it to fit within the data, and you want it to be the same direction. So we know that this is positive, so it's going uphill. And if we do something like this, kind of drag your line around until you find the general direction. So let's see. You want just about the same number of points above as you have below. Maybe like this. Oh. So it looks like I have 4 points above, 4 points below, and then kind of 4 points kind of on the line. So you make your own line of best fit. You decide how you want it to be. Because then we are going to find the actual. So let's see, what is our... So it says, use 2 points to write the line of best fit for this graph. What 2 points could I use to create the line of best fit for this graph? What do y'all think? 1, 7, okay. Okay, so I'm going to write that over here. 1, 7. Negative, hold on. 3, 9. But what about this one right here? This one looks like it might be a little better. Negative 3, 4. So now, how can we find the equation of that line using our calculator? Just like we did yesterday. So we need to put these in. So let's see. Go to Stat, Edit, and we're just going to put in those 2 points. So negative 3 over 4, and then 1, 7. So I'm just putting in those 2 points only because I want the line of best fit, the trend line, that just uses 2 points. And then we're going to compare it to the line of regression that we get from our calculator when we use all of the points. So we are going to go to Stat, Calc, down to linear regression number 4. Okay, so that is our equation. So let's see, we need to type that down here. So it'd be 0.75 x plus 6.25. There we go. So this is our trend line. Okay, let's go over to the other side. I'm really having problems with my computer today. There we go. That'll make it a little easier. Okay, let's look at the other side of this page. So we need to type all of the points here from our scatter plot. So I'm going to give you a few minutes to do that. And then we're going to use the calculator and all the points to find the line of regression. And then draw the line of regression on the graph and compare. So I'm going to pause it real quick. All of them. That's a lot of points, Missy Saucy. How many? Okay, so I want you to check your points with the points that I have on mine. And then put them into L1 and L2 on stat. Be careful whenever you put these in, and I also want you to double check that you have them in correctly. Whenever I first put them in, I had something wrong. So I had to go back and fix it because it wasn't matching up. And then do your line of regression. There's one thing I need us to do, though, to find the R value. So we'll go ahead and do this, and then I'll tell you about the R value. So let's go ahead and do the linear regression. So let's look and see. We'll go to Stat, Calc, linear regression. Okay, so this is what we get. So we need to write this. So what is the A value?
The A value is 0.9293.
93, because we're going to round it to the nearest hundredth. Okay, and then the B value?
6.02.
Yep. So then our equation. Okay, so let's look at that compared to the one that we did. How did we do in comparison? Yeah, so look at our slope and look at the y-intercept. I would say that's pretty close. Slope is off by less than 0.2. And then the y-intercept is off by a little over 0.2. Pretty good. So we're going to graph that on here. So let's look and see how can we create a new line. I'm going to copy and paste this line and then make it a different color. Green, maybe bright green. So we know that the y-intercept is a little over 6, and our slope is, let's see, right at 6, really, right? And then our slope is like 1, almost. The green one. So it'd be right at 6 for the y-intercept, and then our slope is right around 1. So I'm just going to make this go like that. I would say that's about right. But let's look in our calculator, and we can do the same thing, but in the calculator. So we'll go to y equals, and we'll put in the 2 lines that we have. So our first line is our trend line that we made. So 0.75x plus 6.25. And then our y2 would be the one that we did with all of the points. 0.93x plus 6.02. You need to get off of that. That's not what we're doing right now. Then the next thing we need to do is make sure our stat plot is on. So go second y equals. My plot is off. So we need to make sure that is on. I'm going to change my color. Turn your plot on. I did second y equals to turn the plot on so I can see the scatter plot. And then in order to see the graph, we go to zoom stat. So you got to remember all those steps, but you can do it. All right. So the correct one, which one is the one that uses all the points? It's the red one. Does anybody have any questions on the steps that we did? I know I kind of went fast. Mm-hmm. Mm-hmm. Okay, the next thing we are going to do is figure out the R value. So whenever we are looking at, let's see, I need to zoom out on this. The R value is called the correlation coefficient.
What's the R value?
That's what I'm going to explain. We haven't done the R value,
Okay.
and we got to use our calculator and change something. So the R value is going to be our correlation coefficient. It's our numeric value that assesses the strength of the relationship. So it's how closely the data is to being in a straight line. So we will use our calculator. We have to change something. So go over to your calculator, and we are going to go to mode. Everybody click mode. And we want to turn stat diagnostics on. So that is, go down several, stat diagnostics on. Every time you reset your calculator, it turns it off. And on the EOC, it's going to ask you for the R value. It's going to say which R value is closest that fits this data. So you've got to remember to go back to your mode and turn stat diagnostics on. Okay. Now hit clear to get out of it. And we are going to do the calculate again. So go stat, calc, linear regression. and then calculate. This time it gives you more information. Y'all see that? Okay, so it gives you the A and B just like before, but this time we have an R squared and an R. We're just looking at the R. The R tells us how closely the data is to being in a straight line. So if it's 0.83 and it's also positive, what do you think would be a perfectly straight line? If this was not perfectly straight in a line and it's 0.83, it's pretty close, right? What do you think the R value would be if it was a straight line? A 1, actually, a positive 1. What if it's a negative? Then
It's like
what do you think that the line is then?
slope,
A negative slope, exactly. So we're going to learn more about that. That was just your intro. So we're going to round this one to the 100th too. So 0.83. Go ahead and type that in. So I typed it in right here. Okay, so we've completed this slide. Let's go on to slide 8. Regression, a statistical way to find an equation that, what was regression? That best fits the data linear regression, written as y equals ax plus b. The a represents the slope or our rate of change. And then our b represents our y-intercept. You can graph the scatter plot and the linear regression equation on the same line. Correlation coefficient is a statistical measure for the strength of a correlation written as a decimal. There we go. And the R value is between -1 and +1. Okay, so let's look at this little table or this little number line here. This tells you really what that R means. So let me zoom in. So 0 is in the middle. That represents 0 correlation. So that would be like a scatter plot that doesn't have any direction. Doesn't go positive, doesn't go negative, just dots are everywhere. No particular order, doesn't go up, doesn't go down. The closer you get to 1, the stronger the positive correlation. The closer you get to -1, the stronger the negative correlation. So it's like slope. A positive going in this direction is positive, so it's a positive slope, meaning positive correlation. It's going up from left to right. And then if you're getting close to negative, it's a strong negative correlation, means the points going from left to right are going more in a downhill manner. Okay, so let's look at this. Put the following correlation coefficients in order from weakest to strongest. So remember, the weakest are closest to 0. Positive and negative don't tell us strong or weak. It just tells us whether it's a positive or negative correlation. So what is the weakest? Yep, 7/100. And the next weakest, but getting stronger, 43/100. Then the next one, negative 81/100. And the next one, 87/100. Next one, 98/100. So positive and negative are not important when we're talking about weak or strong. Okay, go and do the next one on your own, and then we'll check it. All right, so let's see what you got. 4/100. 32/100. Negative 42/100. 63/100. And negative 65/100. So the strongest really isn't even that strong because it's not even that close to 1. Okay, so let's do a prediction. Indicate the relationship between two sets of data. If it is a strong positive correlation, what should it be? What do you think we could predict this to be? It's close to, if we look over here, close to 1, but is it exactly 1? No, but it's close. So what could we put? Yeah. 0.9. Okay, the next one. It's a weak positive. So let's look over here. It's positive, so it has to be between 0 and 1, but it's not very strong. So what about half or 6? Because it's not super scattered. Oh, I need to make this bigger, not smaller. Okay, the next one, a strong negative correlation. It's almost in a straight line, but it's not exact. Let's do 8. 0.8. Okay, weak negative correlation. This looks a little closer together than this one, right? So maybe closer to 7, but what do we need to add to it? The negative, because it's going downhill. Did I do this other one negative? No, yeah, I did. Okay. So this one needs to be negative 0. Maybe 6.5 or 7. We're just doing estimations, by the way. These aren't going to be 100%. Okay, the next one, moderate negative correlation. I'd say right about half. What about no correlation? What would that be? 0. There we go. It's just a scatter. You can't tell whether it's increasing or decreasing, so it's just a scatter. Okay. Are we good to go on? All right, let's look at our next set of problems. So a convenience store manager notices that sales of soft drinks are higher on hotter days. So he assembles the data. Find and graph a linear regression equation that models the data. Do the equation and then find the correlation coefficient, and then predict the predict the soft drink cells if the temperature is 95 degrees. So I want you to work with your table group on this problem right here. Okay, so I'm going to pause it. If you're at home, just work alone. Okay, let's see how you did on the first one. The equation. This group right here, will y'all tell me what the equation is?
16.42x minus 621.83.
Okay. Okay, do y'all agree with that equation? All right. And then the correlation coefficient group, what'd you get, Abby?
0.97.
Okay, and then how do we predict for 95 degrees? Plug it in for x. So we would do, it's kind of like f of x, right? F of 95, our function 95. If x is 95, let me zoom in. It's really, really zoomed out. 16.42 times 95 minus 621.83. And then write your answer in words. So how will we round that? What do y'all think about rounding? If we're talking about cells of soft drinks, what should we round it to? What? A whole number. Why? Yep. So we're talking about a whole drink. We're not talking about parts of a drink. We're not talking about money. So we need to round it to the nearest whole. So what would that be? 938? If y'all agree? Okay, cool. All right, go ahead and do the next one.
That's not working.
Okay, so your assignment is just to finish this one, and tomorrow we'll do a couple of worksheets about this to practice this even more.